All right, welcome to lesson 21 and 22. This is exciting. We're about to get into understanding linear inequalities in two variables. And so we've upgraded from our lesson 18 and our lesson 19, talking about inequalities in one variable, and we're going to talk about how to graph linear inequalities in two variables. So, disclaimer, lesson 10 and 11 talk about how to graph equations. If you need to go back, and remember how to graph equations, because we're going to need that, I suggest you go back and watch that video. All the videos are uploaded in your Google Classroom. You have access to all of them whenever. So I'm going to give you a hint now that if this is something that you struggle with, we're going to be practicing and having to do it a lot in this lesson as well. So let's get into it together. So let's find out how to use graphs to represent solutions to inequalities in two variables. So here's the expression 2x plus 3y. I want you to decide if the values in each ordered pair make the value of the expression less than, greater than, or equal to 12. Remember, your value of x is your first value and your value of y is your second value. So for example, 2 times, if I use the point 0 comma 5, that would be, and I would substitute 0 in for x and 5 in for y. So 2 times 0 plus 3 times 5. That gives me 0 plus 15, and that gives me 15. So does that value, is that value greater than, less than, or equal to 12? Right? Tell me if that is true or not. Is 0 comma 5 a solution to my inequality that we're going to see in the next slide? So I want you to take a look at some of the solutions. This graph represents solutions to the equations. The blue circles, you do not have blue circles, but on here they're all blue circles, represent solutions. And the yellow X's, which should just be X's for you, represent non-solutions. I want you to tell me what you notice about the plotted points. I want you to give me a clear, obvious notice of what you have about the plotted points. Do not tell me some are blue. Do not tell me some are yellow. Do not tell me some are X's and some are dots. What do you see about the solutions to my inequality? And so we're going to take a step further and talk about how to represent it. And so just as we had open and closed circles in our one variable inequalities, in this case we have dashed and solid lines. So I want you to take a moment. Which graph do you think represents solutions to each of the inequalities? X is greater than and equal to y, and x is greater than y. A dashed line does not include the values on the line y is equal to x. That is when it is x is strictly greater than y. We have a dashed line because we're not including those values. The values on the line are not a solution. They are a border to tell us where the solutions are, but the line there is not a solution to my inequality. On the other hand, when I have a solid line, all the solutions on the line include the values, right? So it includes the values on the line y is equal to x, so it is a solid line. So that is when x is greater than and equal to y. So when you are graphing, same thing with what we did with one variable inequalities. Determine if it is going to be an open or a closed circle. Same thing here. Is it going to be a dashed line or a solid line? That's going to be one of your parts as you are graphing your inequalities. So let's practice graphing some inequalities. So here's a graph that represents solutions to the equation x minus y is equal to 5. Remember, we found we are able to graph using our x and y intercepts. If you need to go back to lesson 10 and 11, make sure you go back to lesson 10 and 11. Let's talk about what it means to represent an inequality. So I give you 4 inequalities here. I gave you the line or the borderline for what your solutions to each of those inequalities represent. So I will give you one of them. So we are going to, your first step, you want to test a coordinate point that is not on the line to see if it is a solution to the inequality. Your first step first is to draw your line. In this case, it is a solid line because we're talking about something that is less than or equal to 5. It would be a dashed line if it was strictly less than 5 or strictly greater than 5. So in this case, I'm drawing a solid line for you. And then your first step here is to test a coordinate point that's not on the line to see if it's a solution. So I'm going to choose a nice easy one. I'm going to choose the point 0, 0. And so the point 0, 0 is a nice easy choice because I'm just plugging in 0 in for x and y. So 0 minus 0 is less than or equal to 5. Is that a true statement? 0 is less than 5. Yay, we're a great area. We're in a great situation. So if the point is a solution to the inequality, I want you to shade the space that includes that point. If the point is not a solution to the inequality, I want you to shade the other side of the line. So That is all a true statement. So I want you to take your pencil and to shade everything to the left of the line. And so I want you to do the same thing with each of the other points. I gave you the original line. And so you want to use that same line. Oops, sorry, I went you back too far. I want you to use that line for every single one. You want to determine if it's going to be a solid line or a dashed line. That's your first step. So first draw if it is going to be a solid line or a dashed line. Your second step is to test a point. Test a coordinate point that's not on the line to see if it's a solution to the inequality. Once you figure out that, you want to just figure out which way you should be shading. If it is a solution, you're going to shade the space that includes that point. If the point is not a solution to the inequality, I want you to shade the other side of the line. So, like I said, if you need to, I quickly just went over it right now, but I suggest you slowly go over each of those steps and practice it at every point. So I gave you the second part of it. And I want you to give me the other three values here. And so for each activity, I want you to for each graph, match the inequality whose solutions are represented by the shaded parts of the graph. So now here you are given both the inequality and the graph. I want you to just tell me which is which. It's just good practice matching your values to your inequalities to your graphs. And like I said, look for your dashed and solid lines first. Look at which way it's being shaded. Look at the variables. And I want you to tell me if you want to, and test a point, right? Choose the point -2, -2. Is that a solution? Is it not a solution? If it's not a solution, then you know which way it should be shaded. If it is a solution, then you know which way it should be shaded. So we're going to be talking and doing some practice with that over the next few activities. The Saturday market. A vendor at the Saturday market makes $9 profit on each necklace and sells $5 profit in each bracelet. I want your first step. I want you to find a combination of necklaces and bracelets that she could sell to make exactly $100 and more than $100. I want you then to write an equation whose solution is a combination of necklaces and bracelets you could sell to make exactly $100 profit. I want you to write an inequality whose solutions are the combinations of necklaces and bracelets so she could sell, make more than $100 profit. Remember your first step. Determine what information you know, determine what information you do not know. Once you do that, it will make it very, very easy to write an inequation and inequality for your situation. And so, my variables here. What information do I not know? I don't know how many necklaces they sold. I don't know the number of bracelets they sold. I know that it's $9 for every necklace, and I know that's $5 for every bracelet. In this case, I want to make exactly $100. So in this case, my equation is 9n plus 5b is equal to 100. That is my equation. I'm going to practice with you how to graph the equation portion of it, and you're going to go the next step of graphing the inequality. If this is something you're stuck with, rewind the video and go back to the portion in the video where it goes over how to graph an inequality. Solid or dashed line, test a point, figure out where to shade. 3 steps. So, how to graph an equation first? Graph the equality first. So, 9n plus 5b is equal to 100. You use your x and y intercepts. This is lesson 10 and 11 again, like I reminded you all. When n is equal to 0, 9 times 0 plus 5b is equal to 100. You are going to solve for b, right? 9 times 0 is equal to 0. 5b is equal to 100 then. B is equal to 20. So that is your first point that is on your graph. When n is equal to 0, b is equal to 20. Your x-intercept of the graph, 9n plus 5 times 0 is equal to 100. So that tells me 9n plus 0 is equal to 100. 9n is equal to 100, and n is equal to 11.1. You're going to plot your second point on the graph. Once you get to that point, you are going to determine if the line should be dashed or solid. In this case, are we talking about greater than or equal to, less than or equal to, greater than or equal to, right? I want you to give me which one is in my situation here. Dashed or, yep, so if it's dashed, it's greater than or less than. If it is solid, it is greater than or less than or equal to. Your third step, test a point and shade, sorry, that should be SHADE, the correct region. And once you are done with that, you are going to have a completed graph. I should see a completed graph here. This is an incomplete graph. I just gave you the first 2 points so that you can connect your line. First, determine if the line should be solid or dashed, and then I want you to test a point and shade the correct region. So at the end of our lesson tomorrow, given a two variable, or in the next class, sorry, given a two variable inequality and graph of the inequality of the related equation, you can determine which side of the line the solutions will the inequality fall. And I can describe the graph that represents the solutions to an inequality in two variables. So we're going to be doing a lot of practice during class, but I want you to make sure that you remember those three steps. If you need to go back and watch this video a couple of times, or go back to lesson 10 and remember how to graph equations, then that might be something that is going to be very helpful as we move forward, because it's only going to start to collect in lesson 23 and 24 and 25. So I look forward to seeing you there.